Okay, good afternoon, everyone. I am incredibly cold, so hopefully I don't forget my name while talking today. I want to say thank you to the organisers for inviting me to speak. This is one of the globally recognised conferences, I'd say, and it's really an honour to be here, a privilege, particularly to talk about sustainability. So I have 25 minutes to talk you through 3 years of our work as IXO partners. Look, 25 minutes isn't very long, and there's some pretty extensive ground to cover. At the end of the presentation, I'll put my contact details on the screen, and very happy to have a chat afterwards. Particularly around sustainability, the definition varies depending on what client group you are talking to, depending on their interests. So what we have been trying to do for the past 3 years is take all of that knowledge and distill it down to the principles we understand as facade designers, as facade contractors, as architects, as developers, as builders, and then as building users after that point. So, here we go. An agenda. First, I'm going to talk about ourselves very briefly so that you understand my background, the company's background. Then I will present sustainable systems, which is a kind of high-level topic, distilling it down to facade responses, and then key takeaways for facade contractors and product suppliers. So a quick intro to us. We are co-founded by 2 women, myself and Vimal Karpe, who is unfortunately unable to be here today. She really wanted to come. We are based in Hong Kong, although we come from different places in the world. I'm originally from Australia. She's originally from India. We founded our firm in Hong Kong because it is the gateway to kind of the modern industry, the world as we know it. Together we share 30 years of construction expertise. She's a structural engineer and I'm a facade design consultant. The thing that links us together is that both of our educational backgrounds are civil engineering. So we understand at a very large level what enormous systems look like on projects, down to the very small details that are delivered and the risks that are tangibly linked to those. What does IXO stand for? We're inside, cross, outside. So as the structural engineer, she represents the inside of buildings, primary structure, and I am, of course, the envelope, the thing that goes on the outside. Got a clicker. This is my very brief background from kind of concept design all the way through to construction. I've spent a lot of my time doing forensic investigation, both in Sydney, Hong Kong, some bits in the Middle East. So we really look at the full life cycle of projects. Our backgrounds are global. The only places in the world we have not touched are Africa, Tom, and South America, and then of course kind of upper Russia and the rest. We have 2 offices, so we've recently established in Mumbai and we also have our office permanently in Hong Kong. We, for the last 3 years, have worked on projects that are highly confidential. And the reason that they're highly confidential is because we're working outside of the building industry and now at the upstream element with investors. And they don't particularly like when we go and talk about sustainability because they want everyone to know that they're already doing the most sustainable things. So what I will do today is talk to you mostly about our Middle East projects, which represent a large portion of our work to date. One of the projects is on the left here. So number 1, I can't tell you the name, but I can show you the photo. We worked on this last year. And previous to that, we had worked on the regional planning concept, so up on level item number 4. I also want to talk to you about project number 2, which was around innovation, green innovation in the sector. But before I talk about these projects, we've got a lot of other stuff to talk about. So, quickly, what are sustainable systems? I am going to briefly show you 8 projects that in their different ways all represent sustainability. These are not projects I've worked on, but they are ones that we have looked at in terms of research, how they were built, and how they continue to contribute in a sustainable way. So, is the most sustainable building a smart building? Is it the building that provides access to nature? Is it the building that has been designed to embrace passive design principles, the one that is the most energy efficient? Although, you know, there's a lot of glass on this, so I would debate that. Does it adopt clever materials? There was a lot of design and R&D that went into the materiality of this project particularly. Is it the one that provides the most amount of privacy? Does it reflect solar gains and also reduce energy? Is it self-sustaining? This building in Fukuoka was designed to harvest rainwater. Is it designed to be responsive? Can it develop a second life? The Empire State Building, just as an interesting side quest here, is undergoing one of the most interesting redevelopment I'd say, projects, and has been since 2012. All of the single glazing that was installed on this project in the 1930s, so nearly 100 years ago, was lifted off the building, and in the basement of the building, they had a mini production line to take the glass and create IGUs from that glass and then reinstall it on the building. At the same time, they then looked at insulating the envelope. This is a pretty incredible second life. So does it need to be any, or does it need to be all of these things in order to be classed as sustainable? What we tend to do when we speak to the broader finance community is ask them to think about what they consider to be sustainable. So when a finance company considers itself to be sustainable, it looks at the long term. It doesn't just look at the short term. So in the banking and finance sector, a sustainable company is a long-term company. They look at all of their cash flow. So the United Nations developed these pretty fancy looking 17 development goals. They're still working on more of them. They're quite interesting. A lot of these are quite, I'd say, directly linked to our industry. So there are things about responsible consumption and production, clean water and sanitation, industry innovation and infrastructure. The thing that binds these development goals together is the statement on the left. It's meeting the needs of the present without compromising the ability of future generations to meet their own needs. Now, that is an incredibly big statement. So I'm going to break it down into 2 risk principles that we speak to and things that kind of mean a bit more to us. So the first part, meeting the needs of the present without compromising. Meeting the needs of the present. So what's the risk if we don't meet the needs of the present? Oh, the clicker's not working. This becomes our prime risk number 1. What if we don't meet the needs of future generations? This becomes our second prime risk. Together, we call this concept the sustainable risk paradigm. It's not a paradox. A paradox talks about contradiction. A paradigm talks about a new way of thinking. A way of thinking that, if I'm honest, I think the facade industry has a pretty good understanding of. You know, we talk about long-term sustainability in terms of specifications, so durability. We talk about warranties. We talk about service life and maintenance. So we understand this kind of at a very different level. So how do we respond to this? We have a sustainable systems response. Now, the things on the left I've put as part of a facade, kind of overarching facade response. What happens when we start thinking more long-term than we currently do? So what happens if the future environmental conditions change? Suddenly, all of the aluminium and the steel and the glazing and the thermal modelling that we've produced for today, for the static conditions today, may not be relevant, right? So this is a huge uncertainty right here. And this uncertainty around environmental conditions then impacts all of the other things that go with it. So in that, let me see if I can do this properly. No. In the top bubble, are the systems maintainable? What will the degradation curve look like? This is immediately impacted by the changing climate. Other things. If we do incorporate responsiveness, so if we decide a kinetic facade or a passive adaptation strategy or biophilic design is the right design for our project, will it work? Not just today, but will it work in the future? And if it doesn't work, can that be translated into something else meaningful for those future generations? How do we integrate new technologies? How do we do it today? How do we make sure it's adaptable in the future? Can the systems adapt? Should we be improving not only the indoor comfort, but also the outdoor comfort? So we have a building, we have a facade, we're starting to look a bit more at reflectivity, the urban heat island impact of sun being re-radiated off facades. At the moment, we do that a lot in terms of city users that drive cars. What if that becomes a city user that's a pedestrian? What if those people start to have much more of an interest and a voice in this? And then, of course, where was the material source? This is the carbon equation. Are materials replaceable? This is a circularity question. So what we then have is this traditional practice on the left, which is forward-looking, but then we have future conditions. So we have a new normal practice here. And together, we essentially call this the sustainable systems response. So how do facades contribute? What can we do to make this a tangible response? Here's our fancy diagram. We're going to strip away everything else, and we are just going to talk about cost and safety. Now, these are two things that people immediately understand. Sustainability is a very broad concept. People have different ideas. Innovation, not innovation, complexity, simplicity, all of these things. Cost and safety are primary. So these have traditionally been the levers that we use to respond to facade system risks. And here we're going to look at the idea of using these same levers to respond to today's and future risks. So cost effectiveness. Of course, there's capital costs. Everyone knows about capital costs. This is the budget, right? How much can you do for the least amount of price? Simple. Are there other more durable systems? Maybe not so simple. How much will it cost in construction? But also, how much will it cost in defect management? So a lot of these things start to step into the realm of a client that's interested in their long-term investment, which may not be the case in a lot of these things. However, there are then opportunities to go and speak to the other guys who are buying the building and asking for the recladding. So if they're buying a building and saying we would like to retrofit this from the ground up and do a deep retrofit, then potentially they'd be interested in the defect management. How many defects are currently inside the building, and what will it take to get it to a normal condition? Then we have future. So we all know about the thermal side, the impact of facades on buildings. It's difficult to tangibly link that. And I know that there are systems and processes and regulation, but at the end of the day, the journey from ASHRAE conditions through to, let's use, for example, the American conditions, so the NFRC, LBNL, Therm window, and then back to the kind of mechanical plant and operating conditions, that's still a link that is not very well done. And one of the reasons it's not very well done is because people do not like talking to each other. They don't like communicating. They prefer to sit at their table, do the calculations, pass it to the next guy. And this is a human response. This is not a pot, kettle, black situation. This is just how we like to work. We don't tend to go out and instigate inquiries or investigations. So the one thing that I would say about the air conditioning systems working harder in the future than they do now, the future for air conditioning systems is unfortunately already here. So a lot of the set and forget systems, which were great, I'd say, up until about 10 years ago, they are becoming seriously problematic now. So the air conditioning systems are so tangibly linked to Facade that it's almost unnecessary to talk about these things anymore. The client will tell you, you don't need to convince them. Now, the other thing here, which is really interesting, which we also don't talk a lot about in Facades, is insurability. Insurability of a building is the building's value. If the building is not insurable, it has no value. Now, there are places in the world where insurers are no longer providing insurance. And a lot of these places are subject to, let's say, flooding conditions or fire. They're not yet facing the extreme temperatures that we expect, but it's not far away. We are seeing reluctance from the global insurance sector about extending property premium insurance to certain areas. And this is a really terrifying tipping point, because as soon as a building becomes uninsurable, investors walk away. This other one, the waste cost. Now, this is also something that's quite tangible. There are cities in the world, countries, that sell their waste to other countries to dispose of that waste, particularly construction waste. This dismantleability, recyclability is therefore tangibly linked to how much it's going to cost someone, either the city or the building owner, to deconstruct and reconstruct a building. So it's very likely that we'll see, as a result of the waste cost charges that are coming in globally, it's very likely that we'll see far more interest in retrofitting simply due to this, simply because the cost of deconstructing and selling that material to someone else to dispose of is becoming too high. Second one is safety. So safety, like cost, has many heads. It is a many-headed snake. The safety that we understand is how safe will a building be physically. Let's kind of make sure that it does not degrade structurally, that its physical performance is there, that panels don't fall off buildings. This is our primary safety risk. Keeps us all awake at night. The other things that revolve around safety today are around accessing the building post-installation. Are the building maintenance the building maintenance units, are they correctly designed? Is the person who gets into those sure that they've been rated? How sure? How safe is it that they're going to go down the building, across the building, and who knows what those conditions are going to be? So obviously the safe in situ. Now, the other thing about safe in situ, though, is that if we're starting to think about changing environmental conditions, so we know that, let's take, for example, Sydney has a predictive idea of, based on historical data, of the number of hot days, cold days, humid days, and we tend to design within those kind of environmental conditions, and we apply codes and standards that are built in, into those ideas. If those conditions change, so we start to see more extreme hot days, not only more extreme hot days, but combined with humidity, what does that do to a degradation cycle? How safe will those systems be if they break down faster than what we had designed them for? And then we have future. So here, long-term health impacts. This one at the top, so how safe for the building occupants' health? Now, this is a question that had originally generated the LEED standard. So if you look at the LEED standard, which is the US sustainability certification, very well known, it had originally looked at sick building syndrome. Sick building syndrome is where you end up with mold captured inside the envelope and people become incredibly unwell. What happens if we have to return to that? That becomes a predominant condition if suddenly we don't know what our design conditions look like in the future. The second one, how safe for citizens, was something I touched on earlier. The heat island effect is something that most cities are looking at. We have been looking, IXO has been looking at codes and standards in Australia and India and Hong Kong, and looking at what happens if you have a high reflectivity of facade. So most of these cities are highly glazed, and you're standing in the ground plane and suddenly the sun hits and the temperature goes from 43 degrees Celsius to 55. Pretty unsafe. Cities are looking at safety. Safety for their citizens, because safety is an economic principle. And finally, beyond design life. So how safe is it to deconstruct again? Can we send the material back to the original factory and safely pull apart the glazing? Can we safely look at the photovoltaic, reduce it to componentry, and the person in the factory won't die because suddenly all of the materials are so unsafe, have released some chemical gases over their lifetime, this kind of stuff, right? So human safety. And then also, how safe are the products? So if we do end up sending them to landfill, what will that landfill look like in 50 to 100 years? Will the chemicals used in construction, even though they might have been low VOC, volatile organic compounds, even though they're that, will the combination of those materials in landfill produce some other environmental footprint that we should have known about? So why does it help us to apply this lens? I mean, obviously cost and safety. Because of the middle bit. So we're also facing, at the same time that we are unfortunately looking at global events, we're also facing a complete disruption in the world that we have known to date. And the reasons are worsening weather conditions, so more unpredictable, acute, problematic, difficult to figure out weather conditions. Power grids. Electricity is under pressure at a rate that has never been seen in the modern world. Rising insurance costs, not just for property owners, but also for contractors, also for professionals. Also access to insurance, which I did not put here. But if we talk about some of these areas, like, let's take, for example, Melbourne. Melbourne has instituted about 5 years ago a requirement for facade consultants to come from only 3 backgrounds. So they have set into their codes a requirement that you need to be a mechanical engineer, a structural engineer, or a civil engineer to be a facade consultant. That automatically cancels out 90% of the facade consultants in Australia, maybe more. Some of my best friends and some of the best facade design consultants I know are not engineers. 1. It also makes it really dangerous to be an engineer, because it means that you've got a narrowing of interest in the industry on a particular kind of focus. And engineers, I have to say, are very good at looking at certain typologies of problem, but sometimes not the best at looking at the entire spectrum of issues that we face as facade consultants. And that cuts across things like maintenance, things like factory inspections, quality. There are people that have fabulous and very direct skill sets that are automatically cancelled out, which makes it more dangerous then, because it means that those skill sets are being missed in a place like Melbourne. And that risk is captured by the insurers. So if I want to be a facade consultant in Melbourne, my insurance premium triples. So insurance is a really big one. Lagging building standards and codes. This is also really problematic. I mean, without getting into any of the politics of this, last year, the Department of Energy in the US, which was one of the largest research and development arms globally, was effectively defunded. Now, the Department of Energy in the US is responsible for, or had been responsible for, helping the world understand what photovoltaics would look like. So they had an entire arm that was just dedicated to the design of photovoltaic fields. Now, that entire section has been defunded. So who is going to take up that R&D opportunity? What else? Supply chain disruption. This is an obvious one. I mean, we've been dealing with this since COVID. I have a feeling the supply chain disruption has just got worse in the last 2 weeks, the results of which will be recognised very soon. And then the last one, which is reduced and more restrictive project financing. Basically, investors would like to know exactly where their money is going and exactly what the return on investment is going to be. And they would like that to be 2 years. They don't want it to be something like 50. So this reduced and more restrictive project financing is responsible for a lot of budget cutting, closures of certain projects. I have to say, particularly in the Middle East, where we've been working, the Public Investment Fund, so PIF, has been defunding a lot of the projects, which then creates uncertainty in the industry. On the top one for a second, so the scarcity of skilled labour. This one is really interesting as engineers, as contractors, as designers. There are fewer young people coming into our industry. And I know that we have AI and all of these fabulous products, but it's happening at the same time that a lot of the original initiators of the facade industry are exiting. So we have fewer people coming in that we can train, and we have the original team of facade design professionals who, you know, did fabulous things in the 80s and 90s. They're starting to retire, which is what they should be doing, but there's just not enough expertise in the industry. So what does this mean? We have a facade response boiled down to 2. We have all of these additional impacts. What we have previously seen when something like this happens, and actually feels more pertinent today, because the last time something of this magnitude happened and you had the convergence of this risk was in the late 70s and the early 80s, the oil shocks. And they changed largely the way that manufacturing happened, capitalism, and this idea of being able to procure elements overseas. And it really changed the face of innovation in our industry. It made us more technologically advanced. So we are kind of at this point again. So now, with all of that backdrop, I'm going to talk through very briefly materials and systems. This is a project we worked on in Hong Kong over 2 years. We worked with a green investment platform, They were looking at late-stage technologies, so technologies that had been trialled elsewhere in the world, and bringing those to Hong Kong and around Southeast Asia for immediate application on projects. These are the types of innovations we were looking at. Some of them spanned across, obviously, kind of carbon cure. We also had a very interesting waste product, a tiling, Createra. EcoSem is exactly what it sounds like. It's a cement-based system. Another few here. Straw texture, quite interesting. Looking at straw as insulation, so the byproduct of the agricultural industry, and then using that as kind of a circular upgrade into facades. There are many. We looked at something like 30, right? And these are products that have been funded predominantly out of Europe and the US. A lot of them have been applied on projects and quite successfully. This one here, Phase Change Solutions, was personally one of my favorites. It looked at taking natural food waste, converting it into a phase change material, and then using the 3 minutes remaining. Then using the phase change material as an insulator. So a phase change material is something that can change state. So it changes from liquid to solid or solid to liquid. And it basically absorbs heat and keeps things cool. So really quite kind of interesting things. The one that I always find more interesting, because at my heart I'm actually a lo-fi designer, not a hi-fi designer. I like drawings on paper, maybe not technology. These things are kind of system ideas that are very tangible to facade design. So the first one is modularity. This is something we know so well, particularly from the background of curtain walling, from unitized systems, whether they're semi-unitized, fully unitized. Modularity takes on this entirely new perspective when you start looking at primary structure, when you start looking at mechanical engineering and the services that then tie in. So how do you design modularity into a system that includes all of these different stakeholders and then all of the risks that are tied in? The second one is around technology, but more than technology, it's about integrating ideas that come from other industries. And this is not new, actually. I say new ideas, but Facades has an incredibly close link to the aerospace and automotive industries. A lot of our codes and standards come from those industries. So what does it look like if we go back and speak to car manufacturers? What things have they been working on in the past 30 years that we can bring into our processes? Is there someone who's designed something particularly around, let's say, wind streamlining, so water, kind of wind shedding? Is there someone from the aerospace industry that has a really interesting material that we can use? I know we work in aluminium, steel and glass, but is there something out there that presents something quite different in the way that we design or think? These are the types of things that I have to say really make a difference when you're going to speak to a developer, because they know, or at least they think they know, exactly what it is that a facade does. So if you start talking in terms around innovation, providing an idea or an interest that's different, it sets you out from the crowd, and it really then generates interest in a way that's quite different. So I've got here, if my clicker will work, I'm sure I'm out of my 3 minutes. So these two things are really critical for us. First one, improve the perceived value. Everyone knows how to do what they do, but we're all very bad at communicating what it is that we do, if I have to say that. Know your product. Go back to your roots. Understand how your fabrication processes work. Share as much information as you can, obviously, without giving away your IP, but think about what everyone already knows versus what it is that you do differently. Know your market, so understand the local conditions, environmental, weather, regulatory, financial, manufacturing, these are obvious. Extend the product potential through innovation partnerships. So could you look at partnering with someone who's interesting, who has a novel idea? Could be a kinetic designer, could be a hardware manufacturer, could be someone that sits completely out of the industry that has something that could be a tangible idea within hours. And then, of course, the second, which is improve the value by communicating it. So talk about trade-offs. People are not very good at understanding sustainable concepts unless you start talking about trade-offs. So yes, you can have this facade, but hey, it doesn't perform fabulously. If you want to have something that is even better than the design that you have currently, or if as an investor you are considering owning this building instead of selling it, then you might be interested in long-term performance. You might be interested in the cost of your energy bills. And the last one is adopt a pull, not a push approach. So this thing about transparency is, I think, was covered in the earlier section. We talked about trust. Transparency is key, honestly, to trust. I'd say beyond the pull, not push approach, the thing about communication is that even when people speak English, they use English differently. So as an Australian, I have a different language, a cultural difference to an American, to a Brit, Irish, anywhere, right? Or even as a second language. So just kind of think about when someone is asking you something, whether they mean to be abrasive. I mean, Mike was talking this morning about empathy with contractors. The same applies when you're sitting in a project discussion, in a tendering, and someone says, hey, I don't understand that. It could be that there's a communication gap. So the way that communication needs to be jigged, changed for that discussion to have a successful outcome. That's it.